Alright, so the next section will teach us how to graph all of these without using our graphing calculators. We're going to fudge this just a little bit and actually use the graphing calculator so we know what the shape looks like. For this chapter, I want us to focus on the asymptotes and the x-intercepts. So we're going to focus here on, after we simplify, 3, 4, and 5 as our steps. And then we're kind of just going to use the graphing calculator to do 6 and 7. Alright, so zeros for the numerator, zeros for the denominator, and then we'll find our horizontal asymptote. This is going to be the key to all these graphs. So for example 3, we're going to sketch this. Alright, 3 over x minus 2. Right away, I know that my vertical asymptote is x equals 2. I know on this one that my horizontal asymptote is y equals 0. Now why do I know that? Because the degree of the numerator, x to the 0, is smaller than the degree of the denominator. Anytime that the numerator is smaller than the denominator in terms of degree, we say immediately y equals 0. So we're not going to cross y equals 0. We're not going to cross x equals 2. And we do know the general shape of this. Since it's a positive 3, this is a positive example of the 1 over x parent function. So it's going to look something like that. Now, why didn't we get any x-intercepts? Well, we never crossed the x-axis because the horizontal asymptote is y equals 0. If we never cross the x-axis, we can't have any x-intercepts. Alright, so let's go ahead and try the next problem. Try 31. Alright, 31, part A, the domain. Immediately we can say x does not equal negative 2 from the denominator. For part B, let's identify all of the intercepts. There are going to be no x-intercepts on this one because there's nothing to deal with on the top. We're going to say 1 equals 0. That never happens, so we'll have no x-intercepts. For C, find any vertical and horizontal asymptotes. I know my vertical asymptote is x equals 2, and I know that my horizontal asymptote is y equals 0 because the degree of the numerator is smaller than the degree of the denominator. And D, plot any additional solution points as needed to sketch the graph. This is where we're kind of cheating a little bit on this section. We're going to come back to this in more detail later, but right now we have 0, we have x equals 2. We know that this is a positive 1 over x parent function, so it's going to look something like that. And we can always check on our graphing calculator just to make sure that we've done this right.